Hi, bonjour. Let's have a look at this question here. Physics Standard Level Paper 1 in November 2022, number 3. The same question appeared in the same session. For higher level, it was number 4 in paper 1. Here is number 3 in standard level. It is exactly the same question. So, ball 1 is dropped from rest from an initial height h. At the same instant, ball 2 is launched vertically upwards at an initial velocity u. At what time are both balls at the same distance above the ground? Okay, so here the keywords here, we have two balls, right? The first ball here is dropped down and is dropped from rest. From rest means what? Means the initial velocity is 0, right? So I can say, okay, so for ball 1, right, we have the initial velocity u is equal to 0, while ball 2 and actually is going down. So ball 1 is going down, which means the acceleration here has to be the free fall acceleration, right? And since it is moving down or dropped down, so it's going to be positive g, let's say. Okay, now for ball 2 is launched vertically upwards, right? So then the initial velocity is u, so we have certain initial velocity, but then the acceleration has to be negative g because it's launched upward against the gravity. So the acceleration here is going to be negative 9.81 meters per second squared. Here I don't need to actually worry about the numbers here. I can just write it as g. Okay, so now we have time here, and we say what time and talk about distance. So think of kinematics equation, right? So what is the most suitable kinematic equations here? S, probably the distance, right, is equal to ut plus 1/2 at squared. So this is basically my main equation here I'm going to use for each ball. So here what I can do here, I can say, okay, now I have here actually the vertical distance here, you know, reached by ball 2, and it is the same time when ball 1 also like meet, right? So the same distance above the ground. So basically this point here as in the schematic here. So let me call this distance here, I don't know, s. Okay, so this is the vertical height or the vertical distance traveled by ball 2. And then at this moment here also, ball 1 traveled this distance here from height total h, right, all the way down to this point. So basically the vertical displacement traveled by ball 1 is going to be h minus s, right? Is going to be this full height here, right, minus s. So at this point here, you know, both balls, you know, will have the same distance above the ground. Okay, so let's apply the kinematic equation. So let's say, okay, so for ball 1, now s here for ball 1 is basically h minus s in this case, because this is the distance traveled, you know, by the ball, right, downwards. So h minus s now is equal to ut. Now u is 0 because it is from rest, right? So I can say h minus s is equal to 1/2, and then instead of a, I'm going to put g and then t squared. So this is the same time, you know, when it reached that height here. And then for ball 2, right, and instead now the distance is going to be just s, because this is the distance traveled vertically upwards by ball 2. So I can say s. Now now ball 2 has initial velocity u, so it's going to be ut, right? And then instead of plus here, I'm going to say negative minus 1/2 gt squared, because a is negative g. Okay, upwards acceleration is minus g. So we have here two equations, right? This is equation 1, this is equation 2. Now we can try to use these two equations to find the time, right? So maybe, I don't know, maybe I can substitute s here in the first equation. So I can say, okay, so from 2, substitute in 1. Okay, so I can, now I have h, now minus, now instead of s, I'm going to put this full expression here on the right hand side. There's going to be minus ut, and then negative times negative positive, so plus half gt squared, and then we have still on the this side here of equation 1, 1/2 gt squared, right? Now here I can see the full term here, 1/2 gt squared will cancel, right, on both sides. So, and then, okay, so therefore you can say h minus ut equal to 0, right? We can say h minus ut equal to 0 implies h is equal to ut, implies t has to be h divided by u. So the answer here is C.